Hello everyone, welcome back to my tutorial. In this tutorial, we are going to solve this truss member using Salome meca. It has a 4 member 1, 2, 3, 4. First 2 member having a cross section of 0.2 and to 0.2 meters. Both are in meter. And next 3 and 4 member having a cross section of 0.1 into 0.1. And these dimension lengths are in mm. So 1 meter, this is in 1 meter. And here they have given a force of 10,000 Newton. And this member truss is made up of steel of Young's modulus 210 gigapascal and Poisson ratio is 0.3. Now we'll model this geometry using a Salome meca and we'll solve it by using code aster. Now I have opened geometry model. Go to basics, points. First we'll create a point one by one. First 0. Then it is in x meter, x length of 1000, that means 1 meter. Just apply, fit screen, this one. Next, x is 1 and y is 0.5, that means 500 mm, that means 0.5 meter. Here you can see x is 0.5. Here you can see x is 0.5 and y is also in 0.5. Now it's coming center, just apply. Now there is one more point which is in 2 meter of length and the height is in 1 meter. 2 meter x, height is 1 meter. Fit screen. Here you can see there is one more point is creating, just apply and close. Now we have created the points, then we will create a line to create the truss. I am just hiding this one. First one is this one, next this, just apply. From here to here. Point 1, point 1 is this vertex 3. This is a vertex 2, just apply. Then from vertex 2, choose this vertex 4, just apply. Then again from this vertex 4 to vertex 3, just apply and close. Now this is the structure we have created, kind of crane. Now we will create a wire from this lines. Go to build wire, just apply and close. Now we have created this wire, this is our truss. Now we'll save this file. Go to Vengat, pictures, code aster. This is the third case. Yes, I'm just saving here. Now we'll create a groups to apply the boundary condition. Go to create group, line group. First these 2 lines add, and this one you just make it add. This is the beam 1 because it has a different section, and these 2 are, just add beam 2. Now we have created 2 different beams. Go to point and this one and this one. See, both these are fixed. Just select this one, add, and this one you just select and add. Both the point I have added, and this is I'm just making fix. Just apply. And here you can see, here we just want to apply a load of 10,000 Newton. Simply I'm just naming it as load. Just apply and close. Now I have created the groups. Now we'll go for mesh module to create the mesh. Select this wire 1, mesh, create mesh. Wire discretization. In hypothesis, go for local length. I'm just giving 0.04. Just say OK and apply and close. Now right click this mesh one and compute. This is the mesh information. We have created 112 edges and 112 nodes. You can see the node value and edge by like this. So we have just created a little fine mesh. Just close. Now we can export this mesh one by using export MED. Here we can do it. Exported. Now we'll create the setup by using a efficient software. Just go to Fixtures, Efficient. So first, this is a mesh type. Start MED linear static analysis. Then go to Analysis. Choose here a beam element material. This is the steel material. We are using a Newton meter unit. So 210 e power 9.3, and density is not required for static analysis, and the software is modeled with the density. So 7860 assigned to all. So material is assigned completely to the all the component. If you want to assign a specific component also, we can group it and apply it. Now go to element type. We just want to create two element type. One is beam element rectangle with a cross section of 0.2 and 0.2. Here you can see first two beams are 0.2 into 0.2 and next two beams are 0.1 into 0.1. First beam 1, here you can see just beam 1, you just copy it, assign to a beam 1, 0.2 into 0.2, just add. Second also assign to a beam 2. This is actually a 0.1 and 0.1. Just add. Now just go to the boundary conditions. Any DDF or node group or mesh group we can go. Boundary condition name, I'm just giving a fixed. Assign to the name called fix. Just fix all the degree of freedoms, because beam element nodes having a 6 degree of freedom of 3 translation and 3 rotations. Just add it. Now we just want to apply the load. This is the point load. I'm just giving a load name of load assigned to a group name of load, small load. In which direction it is in? It should be in y direction. They have given y direction of 10,000 Newton. So negative 10,000. Just add. Now just go to output. Take all the values. Just save the command file. Go to Pictures, Code Aster, Truss. Just go inside. Just save the name as static.comm. Any name we can give. I'm just giving a usual name. It has written, and just exit. Now we can go for aster study to do the file. Before that, we can open and check the command file. Now you can see in element property we have two elements, beam 1 and beam 2. Both are having a same section of rectangle. First beam 1 having a cross section of 0.2 into 0.2 and beam 2 having a cross section of 0.1 into 0.1. Remaining are all same. Now we have done. Just go for aster study. Go to tools, Code Aster, run ASTK. Just OK. This is the ASTK version. First locate the folder, Code Aster. So this is the location. I'm just saving this file. Just save OK. Now we can read the files. So for that, to easy preparing this ASTK, I'm just keeping this windows right side and left side. Now first one is command file, next one is mesh, that is mail, then message, error, resu, finally RMD format. So first two are input format. So type dot slash, then put the name of the command file. Then mail is nothing but mesh underscore one dot med dot slash record. Then message file dot slash message dot mess, then dot slash error dot err dot slash resu dot resu, finally dot slash result dot rmd. Now everything I have written, just give some memory. I'm just giving 1 GB. 15 minutes is much more time. Interactive follow-up. Now we can save this file by using Ctrl S. Then finally just run it. If any error comes, it will stop. Yes. Now you can see it here. This one is a repeating command it shows. Here you can see this is actually a repeating. This should not come like this. So how it has to be is, now see, this is closing the bracket, this is closing there, and this is opening. Now see, here we are opening this bracket and closing it here, and there is one more function which is opening and close it there, and this is to close the complete function. Now we'll save this file. Now little adjust I have done, just close it. Now we'll run this file again. Both. Now we can run it again. Yes, one more bracket has to be closed. So now only it is finally closed. Now we can run this. Now we will open it. Now it is come up with the alarm and no errors. The only modification I have done is, here you can see in the static command file. So I just modify like this. Okay. Now we can open the result file in the paraviews and to do the post processing. So this is the result file. Just go to paraviews. Just right click and open. Pictures, code aster. Just apply. Here completely we are fixing and here applying 10,000 Newton force. I'm just changing the color. Background I'm changing the gradient. Okay. Similarly, we can go for stress, normal stresses, rainbow, we are getting a stress of these are having a less stress because we have the cross section is more. These are having a stress is higher. That is because of the cross section is less. So now in this we have completed this tutorial. Thank you for watching my videos. Please subscribe my channel for more videos. Thank you.